In this video, I'll be deriving all the formulas which you need to solve questions under circular motion. So all the formulas I gave you in class yesterday, we're going to see how those formulas were derived, as it can help you stick better, as it can help you remember better. Alright, so I'm just going to draw a circle to represent our circular motion, and then I am going to draw a straight line from the center of the circle showing 2 points along the of an object along its circular path, and the angle through which the object has moved, which is the angular displacement, is represented by theta. The length along the circular path, the angular length, represented by letter S. That's the distance covered along the circular path. So this was the initial position, then the objects moved here. So first thing we need to understand from circular motion is the angular speed or angular velocity, and this is given by the angular displacement over time. So this is angular speed. Now recall that the velocity of a body undergoing circular motion is always directed tangential to the circular path. Is that tangential? Okay, let me draw this again. So the velocity is always directed tangential to the circular path. That's linear velocity, and that's just obviously distance over time. But angular velocity has to do with the angular displacement per unit time. Alright, moving on. So from this, we also know that from the formula for length of an arc, that theta over (360) times the circumference is equals to length of an arc from mathematics, right? So in this circle, this is the arc which was formed during the motion, that's S. So we can say S is equals to theta, which is the angular displacement, all over 360. 360 is the same thing as 2 pi radians, then multiplied by the circumference. The circumference of the circle is 2 pi r. 2 pi r. That's the formula for circumference. Now we can see that 2 pi cancels 2 pi, and then we are going to be left with S equals theta r over radians, but no need to put that. Then we are going to have theta equals to S over r. Now recall that from this equation right here, we have theta. So in place of theta here, we're going to put this value. All right, so let's do that right now. So W is equals to theta, that is angular displacement over time. And now we have come to realize that theta itself is equals to S over r. Okay, I didn't say what r was. R is the radius of the circle. And now we can substitute. So substituting, we're going to have W. In place of theta, we put S over r divided by what? Divided by time, which means W is equals to S all over r times 1 over t. So this is going to be equals to 1 over r times S over t. Why? The reason I did it like this is because distance over time, recall that this was equals to velocity. So we can say that W is equals to velocity all over r from this. This is equation number 2. This is equation number 1. All right, this can also be represented as V is equals to WR, right? Okay, so let's derive a third equation. Now, from this same formula, we can also say that, we can also simplify, just say that W equals S over R T. But then T, which is time, R, which is radius, and S, which is the distance moved along the circular path. So recall that period is defined as the time taken to complete one oscillation. So the time taken to complete one oscillation, and one complete oscillation around a circle is what? A circumference, right? So S is going to be equals to 2 pi r, which is the circumference of a circle. So I'm going to have W is equals to 2 pi r all over r, but T we are going to represent as capital letter T, representing period, the time taken to complete one oscillation. R cancels out, and I'm going to be left with W is equals to 2 pi over T. So that's our third equation. So we have W is equals to 2 pi over T. Now also recall that period is equals to the inverse of frequency, which means that if W is equals to 2 pi over T, then W is equals to, we replace T with 1 over F. So 2 pi divide 1 over F. Invert, and you have W is equals to 2 pi F. So this can also be represented as W is equals to 2 pi frequency. Let's derive another formula. All right, that being said, let's see if we can relate acceleration. So formula for acceleration is velocity over time, right? Right. So if we substitute velocity here, so instead of V, we're going to put WR over T. R is radius, T is time. Radius is like distance as well. So distance over time, that's R over T, is the same thing as R over T is going to be the same thing as velocity. So that means we have acceleration being equals to wv. So from here on, we also know that w is v over r. So we can say a is equals to v over r times v, and then we arrive at a is equals to v squared over r. This is centripetal acceleration. So we have centripetal acceleration given by v squared over r. Then what about centripetal force? Centripetal force, since force is equals to mass times acceleration, and centripetal acceleration is given by v squared over r, then centripetal force will be equals to mass times the acceleration, v squared over r. Thus, we have our sixth or fifth formula rather, centripetal acceleration mv squared over r. Now it doesn't end there. Inside this equation, we have v squared. In place of v squared, we can use wr. Recall that wv is equals to wr. Tangential velocity is equals to angular velocity times r, right? So wr in place of v, so we are going to square it all over r. We're going to arrive at w squared r squared over r. Cancel out. We're going to be left with what? W squared r. Hence, a is also equals to w squared r. Just remember that similarly, if we are to substitute wr in acceleration here, we can just do the same thing with centripetal acceleration. So F can also be equals to m times w squared r yeah, so this is another formula you should take note of. Also, I want you to know that there is no difference between angular frequency and angular velocity. I'm talking about this. So this symbol here is used to mean angular frequency, which is also the same thing as angular velocity. So it's either frequency or velocity. Don't get confused when you're asking a question. Calculate the angular frequency or calculate the angular velocity. They are the same thing. And the unit is in rad per second, which means radians per second. So rad per second, radians per second. You know where this radian is coming from? It's the radian which we left out here, this little guy. Okay, so to avoid complications, we didn't include it in our derivation.